2.3. Thank you. It's this Freudian slip thing that you started here, Victoria. Uh, yeah, we can skip a chapter. We can, want to end the course early, a week or so. It works for me. All right, so we're going to continue working with functions, and problem number 8 is kind of a good one. We'll do a few parts of it. In fact, most of it. I don't think we need to do every last little detail on problem number 8. But part of what number 8 highlights is the relationship between the input to a function and its output. The input is the x coordinate, and the output is the y coordinate. So for instance, in part A, they're asking you to find g of negative 4. Well, to find g of negative 4, what's your input into that function? Negative 4. So that's negative 4 for x. So you go over to negative 4 on the x-axis, and you find that y equals 3. So g of negative 4 equals 3. How about g of negative 2? What would g of negative 2 equal? 2. Good. G of negative 2, 1, 2, up here at 2. Let me see if I can zoom in a little bit more, make that a little more legible. Let's continue. I don't think, are you okay with that? Could you find like g of 0? What would g of 0 equal? G of 0 would be negative 2. Let's do a little bit more domain and range work here. So we'll start with the domain. The domain is your x values. What would the x values be for this graph? All right, so negative 4 to where? Negative 4 to 4. So that's your domain. Negative 4 to 4. Now, there'd be a hole in the domain if that was a hollow dot as opposed to a solid dot. But it's solid. So the function is defined here at x equal 2. So there's no gaps. So we got the domain is negative 4 to 4. How about the range? Someone else for the range. Oh, really? Don't do that to me. Shout out for the range. Good. Negative 2 to 3. Would those be brackets or parentheses on those things? It'd be brackets on both of them. So it certainly looks to me that this gets down to negative 2, and it certainly gets up to positive 3 over here. Doesn't here, but it's okay. It gets over there. So the range be negative 2 to 3. What else do they ask you? It says find the values of x for which g of x equals 3. Now this is twisting this around a little bit. I want to find the values of x where the y coordinate is 3. So let me just kind of put this here on our graph. I don't think we have to look too far. Here's the line y equals 3. What's the x coordinate that you associate with y equals 3? Negative 4. So the answer to part C is just negative 4 for x. So again, they're looking for where y equals 3, and that x value is at negative 4. So estimate the values of x for which g of x is less than or equal to 0. So where is this graph less than or equal to 0? Essentially that means where is it below the x-axis? For what values of x? Where is it less than or equal to 0? Along the x-axis it'd be negative 1 to, I don't know, 1.8. Yeah, I mean, I'm not going to be busting your chops on this one. If you put 1.7 and I wrote 1.8 in my answer key, yeah, that's fine. The only thing that I wouldn't like would be 2, because it doesn't quite get up to 2. other than that, I'm sure you'd be okay. So negative 1 to 1.7, 1.8, somewhere there. So again, it's an interval. Now, do you think I should use brackets or parentheses on that interval? Included would be brackets. So certainly a bracket on negative 1 and another one on, say, 1.7 and 1.8. But that's where the graph is below the x-axis. Finally, they ask us for the net change in the function between x equal negative 1 and x equal 2. So at x equal negative 1, what's the value of the function? The value of the function would be the y-coordinate there. 0. What's the y-coordinate at x equal 2? The y-coordinate. At x equal 2, it looks like it's 1. So the net change would be the difference in those y values. How much of a net change was there? 1. Just the difference between this y height and this y height. 1 minus 0 is 1. So the net change is 1. Let's try. Yeah, I am. I need one of those big binder clips to consider. All right, for extra credit, somebody volunteer just sit up here and hold this for me, okay? All right. I'm surprised that there's not like a rush of people. I mean, usually, offer of extra credit can get anything done. I can get my oil changed, clean my windows, etc. You offer extra credit, people are all over it. Okay, let's move over to problem 10. And we're going to do problem 10C and I think 10E. So let's see, it would help if I get the graph a little bit too high. There. So I like this problem. Again, it's asking you to relate a couple things that you have to understand what this means. F of x equals g of x is what they're asking you for. Where is this true? Well, when I'm talking about f of x, I'm really talking about the y coordinates. So, rats. Where are the y coordinates equal to each other? For what values of x? Well, I see a few of them. Yeah, 2, 5, and 7. That looks like where they're equal to each other. Do you agree with those? 2, 5, and 7? Okay. Let's answer part E now. It says find the values of x for which f of x is greater than g of x. Now let's keep in mind that f of x is the blue graph and g of x is the red graph. It'll show up better on the video than it does here. Let me try one thing. Maybe that'll... Does that help at all? No, probably not. Okay. But I want the values of x for which f of x is greater than g of x. So those are going to be intervals along the x-axis. Where does f start being bigger than g? At what point of x? 2. And it's going to stay bigger than g until they meet again. So 2 to 5. Is that it? Is that where that stops? F of x is only bigger than g between 2 and 5? Yeah. And this little piece here as well. This is part E. It's part E. Actually, you have to you'd express it in terms of two intervals, from 2 to 5, and from 7 to 8. Those would be the two intervals where those are true. Now, when I express these in intervals 2 to 5, 2 comma 5, should I use parentheses or brackets? Parentheses. Parentheses because I got a greater than, not a greater than or equal to. They're equal at 2 and at 5. So at 2 and at 5, this wouldn't be true. It's just between those. Same thing with 7 and 8. Actually, not quite 8. What's going to be different about 8? Yeah, 8 can be a bracket. So overall, section. So problem number 10, C was 2, 5, and 7. 10E is 2 to 5 in parentheses, union, parentheses 7 comma 8. And 8 would get a bracket on that one. Any follow-up or comments on problem number 10 here? I only did a couple parts of it, but I think the rest of it's somewhat redundant. Okay. Let's move on down to problem number 16. And in problem number 16, we'll kind of do this two different ways. We'll do two versions of problem 16. So we're going to look at the domain and range of f of x equals 3 minus x squared. Now, it would help us if we could kind of figure out what that graph looks like. And to do that, let me maybe flip this around. Negative x squared plus 3. Sorry about the problem with the focus here. So what's this graph going to look like compared to what we're familiar with? Y equals x squared. It's going to be flipped down, so it's going to open down, and it's been shifted a little bit, right? Shifted which way? Up 3. All right, so shifted up 3. So let's take a look at that graph here real quick. Let me shut these off. So I want y equals negative x squared plus 3. And turn that one back on. And it does exactly what we expected it to, right? Shifted up by 3, so you got a vertex here at 0, 3, and it opens down. Let's figure out the domain and range here. So the domain, you can figure out the domain a couple ways. You can figure it out based on the function or based on the graph. Let's think about it based on the function. What are the kinds of points that we need to throw away when we encounter them from our domain? What kinds of points? Places where the denominator is 0. All right, that'd be one kind of point. What's another example of points that you have to throw out of your function's domain? Where the square root is negative, right? So we can't have either of those. Now, are we going to encounter problems like that for a nice little function like negative x squared plus 3? No. So your domain is everything. We don't have to throw out any points. It's negative infinity to infinity. And you can see that this graph kind of goes on forever in either direction. My functions or my window is just not tall enough to show that, but it does. So our domain here is everything, but that's not quite true with the range. The range is your y values. So what are the y values? Good. Your y values go from lowest to highest, so negative infinity to 3. Now Jeff did the hard part. Someone else finish it up. Am I going to use bracket or parenthesis on 3? Bracket, because it includes 3. You can see that that point is on the graph. Yes. Yeah. Nice observation. If that was hollow, if this point for some reason wasn't on the graph, then yeah, I'd use a parenthesis there. Now the function itself, or the actual problem 16, they make a little restriction here. So let me go back to our sheet here. The actual graph that they give you to work with is 3 minus x squared, and they restrict x between negative 3 and 3. So kind of by default, that's going to be our domain. Now there is a way to do this on your graphing calculator. If you're terribly interested, maybe I'll show you later. But for right now, let's work it on Desmos, because it's very easy there. And we'll take a look at the graph with those restrictions. So you just type in a curly brace. And then I want negative 3 is less than x is less than 3. And what that's going to do is it's going to restrict my function to those values of x. So notice it kind of cuts it off. Cuts it off at the knees. Undefined. You know what? I wonder if I can make that a less than or equal to. Yeah, here we go. Less than or equal to. Less than or equal to. Beautiful. That should define them. No? Not that we necessarily need to define them, but that's changed our range. Our range no longer goes down to negative infinity. Now, in absence of actually counting squares here or something like that, can anyone tell me how I could figure out what the new range is? How far does this function go down? You can just plug in a 3, right? If you plug in a 3, you get negative 6. So what's the new range now for this restricted function? Yeah, negative 6 to 3. So the corresponding range is negative 6 less than or equal to x less than or equal to 3. That's your range. And that's the way problem 16 is really written, is this part here. We're going to continue to work with domain and range, and part of what I'm going to do here is try and do a little review of stuff that we've done before this. So continuing to work with domain and range, we'll start with problem number 20. F of x is the square root of x plus 2. Well, we can work with this a couple ways. Just a minute ago, I said that when we're working with domain and range, you have to throw out certain points. What kind of points would I have to throw out in this case? Yeah, something that would make the square root negative, or what's under the square root negative. In fact, what I want is I want x plus 2 to be greater than or equal to what? 0. So my range, excuse me, my domain is x is greater than or equal to negative 2. That's my domain. Because for these values of x, and only these values, can I take the square root and get a real number. So that's your domain. If I was to look at this graph and try and think what it would look like when I graphed it compared to y equals square root of x, how is this one going to be shifted compared to this one? To the left by 2. So let's see that. And in doing that, we'll also try and get a visual of our domain and range. So let's get rid of this one. Y equals the square root of x. And say goodbye to you as well. Y equals the square root of x plus 2. So you can see that this graph has been shifted to the left by 2. Have an x-intercept at -2 and 0. So the domain, if you're looking at it visually, is everything to the right of -2, including -2. How about its range, though? It's certainly easier to look at this graph and figure out the range as opposed to calculating it some other way. What's the y values associated with this graph? Emily, want to give that one a shot? What y values go with this? The blue graph. Actually, either graph. So what are the y values that are graphed in blue? From what to what? Yeah, it goes a little bit beyond square root of 2 there, which is your 1.414. It goes from 0 to infinity would be your range. Doesn't stop at the y-axis. No, I see what you're thinking, but the graph goes a little bit farther than that. So the range is 0 to infinity. Is 0 going to get a bracket or parenthesis? Bracket. Infinity and negative infinity always get parentheses. If you accidentally make a mistake on that, I'll probably be forgiving. But infinity and negative infinity do get parentheses. Let's try another one. We'll do this one graphically. Do you want a chance to practice some of this on your graphing calculator? Yeah, why not? Spent big bucks for these things, or at least you took all the time to drop off a set of keys for me. So either way, let's put in the function y equals the square root of 25 minus, or excuse me, negative the square root of 25 minus x squared. So let me clear out these functions. Use the opposite key on the bottom row of your calculator to enter in the negative root. So negative, the second key, and then the squared key. Second key and the squared key gets you to the square root. 25 minus x, and then hit the squared key. Let's see if we can't figure out something about the domain first. I guess the reason I want to do that is because I want to show you a little trick about your calculator. I can't put in just any value of x here, can I? For instance, if I put in x equals 6, what would happen underneath the square root? It'd be negative, right? 25 minus 36 wouldn't work. So what's the biggest number that I can square and still have something less than or equal to 25? 5. Or on the other side of things, I could square negative 5. Negative 5 squared is 25. So it'd be okay between negative 5 and 5. And if you wanted to, you could actually take the time to solve a little polynomial inequality like we did the other day. So problem number, which one was this? 22. F of x equals negative the square root of 25 minus x squared. You could solve this inequality. 25 minus x squared is greater than or equal to 0. You factor this, 5 minus x, 5 plus x. You get two numbers, negative 5 and 5. When you test it all out, actually the other way around, negative, positive, negative, you'll see that the interval you want is this middle interval. So kind of a quick review of a polynomial function there. The reason I want to point that out is because we can use that information to help set our window. I mean, does anyone know what the graph of this is going to look like? Yeah, all right. Not too many of us. So let's let our calculator do the work. Let's set the window between -5 and 5. But where do we set the y coordinates? Well, here's where we do a little calculator magic. There's a zoom key across the middle of this. Press zoom, and then we want zoom 0. Because zoom fit is going to adjust your y windows, your y coordinates, to fit the function. So type zoom and then press the number 0, and it should give you the bottom half of a circle. Yay. Now, it might not look like the bottom half of a circle, but it is. If you look at the point x equals 0, at x equals 0, we've got -5. So it's the that's as low as this function goes. Yes?
How do you know what to change the window to?
Well, we let our calculator decide what to change the window to. We figured out what x coordinates would work here. That was this. We wanted values of x between -5 and 5. And then we'd let our calculator do the rest. So once we typed in that, then it was the rest of that? We pressed zoom 0.
No, I got that, but I mean, like, earlier we did, like, 16. Like, why, how do you know what numbers to put?
It's a little bit of skill, and it's something we can practice. In fact, I think I have a problem picked out that we're going to do today where we do practice just that. You know what? It was back in section 2.2, so we'll have to take a look at that one at some point. But as far as this one is concerned, I let the calculator do the work. I figured out what the x values were, and I said, okay, you take over, you figure out what the y values are. So,
Use the domain, right?
yeah, we came up with the values for the domain and then let it take care of the range. So here's our graph. Let's use this now to answer the remaining question. We know what the domain is. What's the range? Cooper? What would the range be? Actually, I think it goes down to -5. Okay, so the range, well, we've got the domain here, is -5 to 5, and the range is -5 to 0. And I'll use parentheses, or excuse me, brackets on both of those. So it's handy to be able to use your calculator to figure out what some of these look like. So that, in particular with the range. The range is not something you can easily come up with algebraically. The domain, you can do some things. The range, not so much. Yeah, someone's sending me this vibe. Break, break, break. Okay, let's take a quick break here.